Hey everyone, welcome back to my YouTube channel. If you are new here, don't forget to subscribe and hit the bell icon to stay updated. Today we are diving into one of the most flexible structural design pattern, the Decorator Design Pattern. So Decorator Design Pattern, this is one of the structural design patterns. It allows to add new behavior or we can say new functionality in existing object without affecting other objects of same class. So it allows the extension of functionality without modifying the existing code. So we can say like it supports open closed design principle. Like without modifying the existing code, we can add additional behavior on the top of existing object. To understand decorator design pattern, so imagine you are at a pizza shop. Every pizza starts with the common base, the dough and basic sauce, right? Which is the same for all pizzas. But what makes each pizza unique? That are toppings. So you can choose from options like tomatoes, pepperoni, olives, green peppers, and mushrooms, etc. Right? So each topping adds flavor and of course increases the cost. The pizza base remains unchanged, but the final pizza adapts to your preferences based on your toppings you select, right? So now think of this in the context of software development. The pizza base is like an object in your code, so that representing the core functionality. Just like toppings in the pizza shop, you can add different features or different behaviors to this object as needed. So these additional properties or functionalities don't change the core object itself. They simply enhance it, right? So they simply add additional features on that existing object. So this is the essence of the decorator design pattern. It allows us to build flexible, customizable objects by adding new behavior at runtime, just like creating your perfect pizza, right? So let's try to understand the core components of decorator pattern. So at first, so we have always a component that is an interface, and further we have concrete components. Those are the implementations of our component interface. Moreover, in decorator design pattern, so we have one decorator, so it can be an interface or abstract class, and which is also the implementation of our component. From this decorator interface or abstract class, so we will be having further concrete decorators. So concrete decorators are the actual decorators or additional features, just like our toppings in our pizza example. So for example, this component is a pizza itself, so various toppings would be our concrete decorators, right? And further in client code, we will be accessing our objects and we will be fetching the additional properties as per the decorator pattern. So let's jump into the example to understand this whole concept in a better way, and that will be help us to make a better understanding on this decorator pattern. So let's jump into the coding part. So here I will be creating a fresh example of mobile object. So first we need to have a interface, that is component in our example. So let's make it mobile. And in this interface, we have two methods. First one is string get description. And next function is get cost of double type, right? So here, as per this diagram, so this component is our mobile interface, right? Next to this, I need to create concrete component. So basically actual base mobile. So here you can see, so our component is mobile and we need to create concrete component. So in our case, so I will be creating basic mobile. Here I will be creating another class basic mobile, and it will be implementation of our mobile interface, which is the component. And let me implement the methods. So we have two methods. In description, let me print basic mobile, right? And get cost. So our basic mobile is of 1000 CAD. So as per this diagram, so we have created component and concrete component. Now we will be moving on to decorator side. So let's create one class mobile decorator, right? in this decorator. So let me declare this class as abstract. We need one reference of mobile type. So let's call it decorated mobile. So basically mobile decorator is like a wrapper around our mobile class. So which will be providing the additional property, additional functionality on the top of our mobile object, right? So that's why just to act it as a wrapper, so we should have the reference of we should have the reference, or we should have the object that we want to wrap inside the mobile decorator, right? So here, so we are having this reference inside the constructor. We are initializing this. Okay. And one thing more, let's call this protected, because we need to have this reference inside child classes, right? So I cannot make it private, but I will be declaring this protected. As I mentioned in the diagram also, so decorator is the interface or abstract class, which is the implementation of component. So in our case, component is mobile interface. So here we need to implement it from mobile interface, and we need to override both the methods. So basically public string get description, and here what we will be returning. So basically we have decorated mobile dot get description. Let me override the second function, public double get cost, and here we will be returning decorated mobile dot get cost. So let me override this. Now this is mobile decorator. So in this diagram, so this one is the mobile decorator, and from that we will be creating the concrete decorator, right? So concrete decorator in mobile example can be, so let me create first concrete mobile decorator. So that is, so let's call it screen guard decorator. This class we need to inherit from parent mobile decorator, and as parent accepts one reference in constructor, so we need to pass that in super. So public safeguard decorator constructor, and here we have the reference of mobile. So mobile here, and let me override methods in get description. So what I will be doing, so decorated so yeah, so we have decorated mobile. So this reference came from here, from the parent dot get description, and along with that we will be just adding little more description. So additional is screen guard, right? And in the cost, what we will be doing, so return decorated mobile dot get cost, plus we want to add $20 additional. So this is screen guard decorator, where in description we just added screen guard, and in cost we have added additional $20. Similarly, we are creating another decorator. This can be, let's call it mobile case decorator. Okay. And this will also be inherited from the mobile decorator, basically the parent decorator. So extends mobile decorator, and again we need to pass the mobile reference to the super class. So let me create the constructor. So public mobile case decorator and super mobile, and we need to override both these functions along with the base description. What we will be adding, we will be adding mobile case, right? And with the original cost, and for case we will be adding additional $50, right? So now we have two decorated classes. One is mobile case decorator and another one is screen guard decorated, right? So additionally we can add n number of decorators along with the additional properties or additional functionalities, right? For example, if you want to give some accidental protection plan, so for that we can have another decorator. So that will be adding the additional cost to the base mobile price, and it will be adding the description to that. So on we can add any number of decorators. So now let me create the client code. It can be mobile shop, right? Here I need to create main method. So let's create the basic mobile equals to new basic mobile, right? And if I print the description and price, so here you can see basic mobile and cost is $1,000. Now I want to add additional flavors. So for example, here I am creating mobile with new screen guard decorator, right? So we need to pass the basic mobile object here. So let me copy this and print this. So now if I print this, so this is screen guard decorator, right? So it will be adding additional functionality to this. So if I run this, so you can see initially it was basic mobile, $1,000. So now basic mobile with screen guard and the cost is $1,020, right? Similarly, we can add new mobile case decorator and pass the basic mobile. So till this point, so we have mobile object with description, new description and $1,020, right? And here if I want to add the mobile case decorator, so which will be adding the additional cost of mobile case and additional description. So if I run this program now, so you can see basic mobile, screen guard and mobile case, it becomes $1,070. So this way we can add any number of additional features by using decorator functionalities. So this is the essence of decorator design pattern. It allows us to build flexible, customizable objects by adding new behavior at runtime. We can see this example in our class diagram. In this class diagram, you can see, so we have interface mobile, which is our component, and we have basic mobile, that is the implementation of mobile. So this is the inheritance. That's why we have is a relationship. So basic mobile is a mobile, right? And this is the concrete component. And on the right side, we have parent mobile decorator, which is again also the implementation of mobile interface. And from this mobile decorator, which is the abstract class, so we have inherited further concrete decorators, which are the actual decorators that explains the actual behavior or properties which we want to add addition on the base mobile component, right? So we have screen guard mobile decorator and screen case mobile decorator. And finally, we have client code. So we have used exactly the same code in our example. So where we have first mobile component or basic mobile object, and on the top of that we have further decorators which added the additional description and additional cost to the basic mobile. I hope this video makes you understand the decorator design pattern with the mobile example. If you enjoyed it, hit the like button and share it with your fellow coders. Also, don't forget to subscribe to this channel for more such tutorials. Until next time, keep coding. Thank you.